This conference will
So
now be
before that,
recorded.
with the program of the timer, we configured timer as a counter. So generally what happens is a tick is going to happen depending on the instruction cycle if you make use of an internal clock. So for every instruction cycle, a tick is going to happen in the timer register. But if we want, we can configure timer as a counter as well. So when we configure timer as a counter, so we are going to make use of an external clock, that is an event which occurs at the RA4 pin of the microcontroller. So upon identifying either the rising edge or the falling edge, so whenever the corresponding edge is going to get detected at the pin of the microcontroller, the tick is going to happen. And as usual, there is an interrupt which gets generated after there is an overflow from 255 to 0. So we saw taking an event at RA4 pin of the microcontroller with the help of a push button. So after that, we saw how to increment the count. Then apart from that, we started with something called as the clock input output. So as you got to know that some of the peripherals in the microcontroller may need the clock input output for the synchronous data transmission. So okay, there's some doubts. Let me address them. Always, do we need to give external clock at RA4 pin only, ma'am? Yes. So according to how our microcontroller has been manufactured, so according to the data sheet of our microcontroller, a tick can be considered only when there is an event happening as an external clock at the RA4 pin. So always you can take an external clock at RA4 pin only if you want the timer to be configured as a counter. Now, why PSA is 1 in timer as a counter, as we have disabled watchdog timer? Yes. So you either have to write PSA with 0 or you have to write PSA with 1. Now, if you write PSA with 0, you are going to assign the prescaler to the timer 0 module. But I cannot do that. I cannot write a prescaler to the timer module when I'm configuring it as a counter. So that is why I had to write. I don't have an other option. I had to write PSA with 1. So anyway, the watchdog timer is disabled. Having PSA written with the value 1 is not going to affect our program. Okay. So why watchdog time disabling watchdog timer at the start? So for that we did a huge like discussion. I think in third or fourth session of our class. So we discussed why should we be disabling the watchdog timer. Okay. If PSA is equal to 1, if PSA is equal to 1. Okay. See, I think you're not getting my point. I'm saying that PSA should either be written with a 0 or a 1. Okay. And watchdog timer will always be disabled in our controller. The reason why we are disabling it is it keeps resetting my board and it will not allow me to execute the code. So it is necessary for me to disable the watchdog timer. So that is like a compulsory task. So I have kept my watchdog timer disabled. I'm not going to make any changes to it. So watchdog timer has been turned off. Now coming to the PSA. So PSA should either be written with the value 0 or it should be written with the value 1. Now if I write PSA with a value 0, it is going to assign prescaler to the timer module. But I don't want timer to get assigned with a prescaler in that way. So that is why I had to write PSA with the value 1. Now writing PSA with the value 1 will not affect the timer 0 module because I'm assigning prescaler to the watchdog timer which is already disabled. So I don't have any other option of writing either a 0 or a 1. So I should either write a 0 or I should write a 1. Writing 0 will make an effect. So I wrote PSA with the value 1. Is it watchdog timer reset the microcontroller, or it resets the board, ma'am? As we have watchdog timer in the microcontroller, it resets the micro. Yes. So it in fact resets the microcontroller. Okay. Can we proceed? All right. So we were discussing about the clock input output. So when it comes to the clock input output, remember that some of the peripherals may need the clock signals for its communication for synchronous data transmission. So some of the peripherals may work according to the clock signal which gets generated by the microcontroller, or some of the cases the devices or the peripherals may work according to the clock signal which gets generated at a particular pin of the microcontroller. So you have to use either of the like you have to make use of clock signal in order to get the communication happen. So we saw that one of a variant of clock input output is nothing but PWM, which represents pulse width modulation. And I hope you remember what PWM stands for, not the abbreviation, like what exactly PWM represents. So pulse width modulation is nothing but varying the width of the pulse, keeping the period constant. So you are going to keep the period constant by varying the width of the pulse. And can you tell me what is the reason of we varying the width of the pulse? Why should we be actually doing this pulse width modulation? Yes. So the reason why we have to do this pulse width modulation is in order to control the average power which is being delivered to a particular load. So changing duty cycle at a constant time to deliver the required average power, right? So whenever we want to vary the average power which is being delivered across the load, so I have to vary the duty cycle, or I have to vary the width of the pulse, keeping the period constant. Now what happens if you do that is obviously you are going to control the average power, but in order to make sure that the load is feeling as if I'm continuously providing that average load, what should I do? So in order to make the load feel that as if I'm providing continuous voltage across that particular load, what should I do? Yes, I always have to keep the frequency high. So you should get more number of pulses generated, more number of cycles in a given amount of time. So you may have to keep the frequency high in order to make sure the load is feeling as if there is a average power being delivered on a continuous manner. So apart from that, we got to know that there are three ways of generating a pulse width modulated waveform. One is with the help of built-in block, second one is with the help of timers, and third one is with the help of bit banging method. Now yesterday, I mean in the previous class, we started with bit banging method of generating the clock signal. So I took a period of around 1 lakh. So duty cycle was 75,000. So what we did was we tried generating a modulated waveform of 75% duty cycle. So that's the only concentration. I did not concentrate on frequency. I did not concentrate on the period. So I just had to make sure I wanted a 75% duty cycle pulse to get generated. So we took period as 1 lakh and duty cycle as 75,000. In fact, we initially took it a little less. That was also giving me 75% duty cycle. But the problem with that was I didn't have an oscilloscope to see the output. So I was feeding it to a LED. Now, if you keep 75 as duty cycle and period as just 100, the rate at which you are providing the data to the LED will be very fast, that you will see the LED is glowing with less number of brightness, less amount of brightness. Now to see that evidently, I had to increase the value of duty cycle and period. So for certain amount, you could observe that for 75% of the time LED was in the on state, and 25% of the 25% of the time LED was in the off state. So this is what we generated in the previous class. Have you got any doubts in this? Any doubts in this program? Okay. Now, assuming that you have got no doubts in this program, we are proceeding ahead. So the next implementation we are supposed to do is, we will try implementing something called as the LED dimmer application. Okay. So we are going to see something called as the LED dimmer application. Now, what is this LED dimmer is? Generally, you will have an LED. Excuse me. I'm sorry. Yes. So we are trying to design an LED dimmer application. Let me make a note of the requirement here. So it's LED dimmer application. Now, what is this supposed to be done in this project is, I have to vary the brightness of the LED. Okay. So my task is to vary the brightness of the LED. I have to glow the LED with less number of brightness, less amount of brightness, and I have to increase or decrease the brightness according to my requirement. Now, generally, if you have to achieve the LED dimmer application, you will be given with a knob. So you will be given with a potentiometer, which is acting as a variable resistor, and that potentiometer or a knob is going to also vary the voltage across a particular load. Okay. Now that we have not learned how the knob is going to work or how to vary the voltage across the load with the help of a knob, so we are not going to consider knob as a particular input. Instead, I am going to vary the brightness of the LED with the help of a switch. Okay. So we are going to do the brightness of the LED with the help of a switch, and the switch we have already learned is nothing but digital keypad. So we are going to make use of the digital keypad. Now, according to the requirement I take, whenever I press the switch 1, so it has to increase the duty cycle. Okay, whenever I press switch 1, I have to increase the duty cycle. Similarly, whenever I press switch 2, I have to decrease the duty cycle. Okay, so I have to decrease the duty cycle. Now, what is this actually doing is, for example, assume your LED is going to glow with a maximum of 5 volts. Okay, a maximum of 5 volts. Now, if LED is provided with 0 volts, what will be the brightness of the LED? Now, if the LED is provided with 0 volts, brightness of the LED will also be 0. It will initially be in the turned off state. Okay. Similarly, if I provide LED with 5 volts of power supply, what will be the brightness? It will be 100%. The brightness will be 100%, very high to the top. But if I provide LED with 2.5 volts of voltage, what will be the brightness? What will be the brightness? It will be 50%. So very similar to that, I want to achieve the same. You already know, in order to vary this voltage, I want 0 volts, 1 volt, 2 volt, 3 volt. That is always possible with the help of pulse width modulation. So to vary the average power being delivered to the load, it is only possible with the help of, remember, that is the pulse width modulation. So you have to vary the duty cycle. Now, you are going to vary the duty cycle with higher frequency so that your LED will not be able to interpret as if there is not continuous voltage being provided. So you will vary the duty cycle. You will give the you will give the LED with a pulse width modulated waveform in such a way that the LED will not feel that you have not provided the continuous voltage. Okay, so you are going to keep the frequency at least more than 100 hertz. Okay, now let us see how to work with this. So as of now, I'm going to make use of digital switch, digital keypad to increase or decrease the duty cycle. So I'm going to retain this the same. So this is not going to vary. Okay. So initially, let me have the LED glown with 50% duty cycle. So I'm going to keep it as 50,000. Okay. So I'm going to glow the LED with 50% duty cycle, and period I have taken is 1 lakh. Now, what I have to do is I have to increase the duty cycle whenever switch 1 is pressed and decrease the duty cycle whenever switch 2 is pressed. For this, I want the configuration of digital keypad. Okay. Do you think I have to write the initialization of the digital keypad, reading the function of the digital keypad again? So do you think I should be doing it? Should we be writing the initialization of the digital keypad and the function all over again? So that is not required. We already have it written in a separate file in our driver code. I'm just going to copy that. Okay, we have the driver code. I'm just going to copy it. Now to copy a particular file from a project, first you have to open that project. So I'm going to open the project with respect to the digital keypads driver. So under tactile switches, I have to open the project digital keypad. Now once you open the project, whichever file you want to copy, I'm just expanding this header file. I want to copy digital keypad.h file. So you either can copy with the help of Control C by selecting on that file, or you can right click and do copy. Okay, first you have to click on the file, then use Control C, or if you want, you can do right click and copy. So after you did the copy, you can go to the required directory you want to paste. So I want to paste it to the header files of bit banging. So you can right click here and paste. Okay. So you can see there is digital keypad.h been pasted. Similarly, I want to copy digital keypad.c from digital keypad. So right click copy. I want to paste it under source files of bit banging. Right click paste. Okay. And once you are done pasting, you please close this project. So right click and close. Okay. After this, I have to include the header file digital keypad.h. Do not forget that. So you can include it in your main.h file. So I'm going with #include. It's a user defined header file. So you can go with double quotes digital keypad.h. Then in your main function, here I have to do the initialization of the digital keypad. So you can directly call the function init digital keypad. But if you don't remember the function's name, you can open digital keypad and you can copy this name of the function and paste it here. Okay, you have to do the function call, open braces, close braces, terminated with a semicolon. So this is initialization of digital keypad. I don't have to write anything extra because initializing function is ready. Reading digital keypad function is also ready. Okay. Now, coming into the while of one, I have to read the key from the user. So I need a variable called unsigned character key. Okay. Now, how do I read the key from the user? So I'm going to say key is equal to, okay, read digital keypad. So that is a function here. So if you don't remember the name of the function exactly, you can copy paste it here. Okay. Now I have a question. I have to go with read digital keypad function, whether it is a state or a level. Okay, so you're saying it as state. Now assume the duty cycle is, okay, so duty cycle is 50. Just assume duty cycle is 50 and period is 100. Okay, duty cycle is 50, period is 100. Now I'm telling you, initially duty cycle will be 50. Means what will be the brightness of the LED? So duty cycle will be 50 means what will be the brightness? 50%. Okay, brightness of the LED will be 50%. Now whenever I press switch 1, duty cycle will be increased by 1. Okay, I press switch 1, duty cycle will be increased by 1. Now to achieve 100% of brightness in the LED, what should be the duty cycle? To achieve 100% LED, yes, duty cycle has to be 100. Now if I press switch 1, duty cycle will be increased by 1. To reach duty cycle of 100, how many times should I press switch 1? I have to press it for 50 times. And do you think I have patience of pressing the switch for 50 times to show you 100% brightness? Obviously no. So what I can do is, I can keep the switch pressed. Okay. So I don't want to use timers and all. I don't want to complicate it. I just want to keep the switch pressed. And as long as the switch is pressed, I have to keep increasing the duty cycle. Similarly, as long as I keep the switch 2 pressed, I have to keep decreasing the duty cycle. Okay, so I hope you are getting it. Yes, so I have to read it as a level detection. Okay, next. How to check if the key I have pressed is switch 1 or switch 2? So what should I write here? Key equal to? Yes, so I can directly take switch 1. So switch 1 will be representing 0x3e. Okay, so it represents 0x3. Now, whenever I have pressed switch 1, I should increase the duty cycle. So I say duty cycle plus plus. Similarly, if it is switch 2, else if key is equal to switch 2, I have to decrease the duty cycle. Okay, so here duty cycle minus minus. Duty cycle minus minus. Okay, I still have one more question. Should you be increasing the duty cycle beyond period? Should you be increasing the duty cycle beyond period? No, right? So I will have one more condition return. Ma'am, can we write like this? While switch counter plus plus. No swastik. So you cannot take it that way because in case of while of a switch, so you have to read the key. Okay. So while, as I said, apart from this while, you should not be taking any other loop. Okay. So that cannot be taken. Okay. I want to check for one more condition. So I go with logical and. So the condition is I have to increase the duty cycle only if duty cycle is lesser than period. Correct? So only if duty cycle is lesser than period, I have to increase the duty cycle. Similarly, in case of decrement, so how long should I be able to decrement it? How long should we be able to decrement it? So do you think I should decrement even after reaching 0? Okay. So once I have reached 0, I don't have to decrement it again. So I say duty cycle is greater than 0, only then I'm supposed to decrement it. Okay. So remember what happens here is, so we have completed this. Initially duty cycle I have taken 50,000 and period as 1 lakh. Okay. Now whenever the key is switch 1, I'm going to check if duty cycle is lesser than period. So if duty cycle is lesser than period, then duty cycle is going to get increased. Similarly, if key is equal to switch 2 and duty cycle is greater than 0, duty cycle is going to get decremented. Now there is one more problem here. When I press switch 1 and I give the level detection, see, I may keep the switch pressed for certain amount of time, but this operation happens on a very faster rate. So duty cycle plus plus duty cycle minus minus happens on a very faster rate. So if you keep the switch pressed for just 1 second, I think it will reach from 0 to 100% duty cycle. Okay. So for that sake, I will have a small delay return for this. Okay. Only for that sake, just to make sure duty cycles incrementation and decrementation is not happening on a very faster rate. So I'm going to have a small delay. I'm going to write a non-blocking delay introduced. Okay. So if you want, I can keep the duty cycle as just 50 and 100 here. So that would be better. So 50 and 100. Okay. Now I will give a small delay for this with the help of non-blocking method. So it is something like this. If wait minus minus is equal to 0. So I need a variable called wait and I'm going to assign it with 250. Okay. So if wait minus minus is equal to 0, then I'm going to perform this operation. Also after this, I have to assign wait back to 250. Are you able to follow this? Okay. So what happens is, observe. So duty cycle initially I have taken as 50, period is 100. Assume you don't have any switches pressed. So initially you will get a waveform of 50% duty cycle according to this logic. So loop counter is initially 0. Okay. So for 50% of the times LED will be assigned with 1. For the rest 50% of the times LED will be assigned with 0. And the moment loop counter reaches the period, loop counter will be assigned back to 0. So this initially is making the LED glow with 50% duty cycle, because the rate at which I'm providing this is very fast. Okay. So duty cycle I have taken as 50, period I have taken as 100. If I increase this, I will see toggling of LED. Okay. I'm keeping it period lesser. I will be able to provide an average voltage of 2.5 volts to the LED. Now, whenever switch 1 will be pressed, duty cycle will be increased. With respect to that, the average power being delivered to the load also increases, and the brightness of the LED is also increasing. Similarly, when switch 2 is pressed, duty cycle is decreased, the brightness of the LED gets decreased, and also because of the average power being delivered to the load is also decreased. Now observe, I'm going to build this project and see the output. So build is happening. So I think the application is not running. It has got stuck. It is not responding. Give it a second. Okay. Okay. Now, there is a small problem, guys. Whenever you are trying to copy a file from one project to another, so generally there will be a linkage disagreement. Okay. So whenever you are copying a file from one folder to another, so there will be a linkage disagreement. So you are supposed to solve this linkage disagreement. Now, how to solve this is, you will be given with an option of project properties here. So I'm highlighting it. This is project properties. In the dashboard of your project, you will have the option called project properties. You're supposed to click on that project properties. Then there will be a new window popping out. So in that case, you have to click on apply. Okay, don't make any changes. Just make sure the compiler is properly selected. So you have to click on apply, and after you click on apply, it takes few seconds for OK to get enabled. So once OK gets enabled, you are supposed to click on OK. So do nothing else apart from this. Just click on project property. A new window will pop up. So you have to click on apply and then click on OK. Now, if I build a project again, so that linking problem must be gone. Okay, project is getting built. Okay, so ID is literally taking so much of time. So this is like the amount of data which it has consumed. Okay, so give me just a second, guys. I don't know what the problem is with this ID. Let me close this and open it again. Okay, now build got successful, but I gave the project to get closed. So meanwhile, let's see if I have got a loadable file saved. So I'll go to file and do reload, like load hex. So it is the same bit banging. Okay. Now you can initially see LED being blown with 50% duty cycle. Now, as I keep the switch pressed, you can see the brightness of the LED is going to increase. As I keep the switch to press, the brightness of the LED is going to get decreased. Okay. So keep the switch pressed, brightness will be increased. Keep the switch released, switch to press, brightness will be decreased. In fact, let me increase this delay from 250 to 500. So that would be better. Oh, give me a second. Let me just close this and open it again. Ma'am, can we use volatile switch is equal to input pin while switch? Swastik, I think I'm repeating this again. We are not supposed to use any blocking statement, any loops inside another while. So the only while I'm supposed to use is for my application to run for infinite number of times. No other while should be taken. Just wait a second. Let me see if the ID is working fine. I'm not very sure, guys. Meanwhile, I think I can show you the duty cycle. Like as of now, you can just see when I press switch 1, the duty cycle is going to increase, and when I press switch 2, the duty cycle is going to get decreased. And accordingly, you can see the change in the brightness of the LED. So as of now, I have kept weight as 250. So if I press switch 1, it is rapidly increasing the brightness. And if I press switch 2, it is rapidly decreasing the brightness also. Can increase the weight a little more. Instead of 250, I think you can keep 500. That should help you increase the bright little slower in rate, decrease the brightness also a little slower. So let me write 500 and let me save and give it to build. So let it take its time. So meanwhile, I'll show you how to see the waveform at a particular pin of the microcontroller. I understand that we don't have a CRO right in our hand to see a waveform, but we still have options of seeing the waveform being generated at a particular pin. So you can see, you can go to modules and click on something called as the oscilloscope. Okay, so you will get something like this created. Something like this open. So it's an oscilloscope, in fact. So this oscilloscope is the one which is used to see a waveform at a particular pin of the microcontroller. So now what happens in this is you just have to select at which pin of the microcontroller you want to see that waveform. So as of now, you can see there are two channels here. Okay, so there are two channels here. So one channel is in red color, the channel is in green color. So both of them are at the same place right now. You are not able to see it. So here one channel is in the red color, the other one is in the green color. Now assume I want only one channel to be used at a time. So another channel you can keep it off. So I turned it off. Okay, the channel with red color I have turned it off. The channel with green color only I have turned it on. Now I have got the LED given with 1 0 according to the duty cycle. That is the RD0 pin of the microcontroller. So I want to know what is the waveform which is being generated at the RD0 pin of the microcontroller. Okay. So now I'm getting some waveform generated. I have to make some small adjustments here. So time, let me keep it as 0.1. Okay. Or let's say 1.4. Channel 1 is off. I shall go with channel 1. So auto in fact will not work. Like, let me check. RD0. Trigger channel 1.
Yeah.
Okay. Okay, so I think this is not clear. Channel 2 is off, I know. I'm going with channel 1. And trigger is on. trigger is just to make sure I'm showing the signal constant. Okay, 1 second. This ID is also not working. I don't know what is the problem with my system. So I wanted this ID to make weight as 500, but that is not working. Okay, I have another template. So let me open that template direct. Like the site itself is making a problem. So for your channel one is showing what? 1 RST. So that you have to select. So you have to change this and you have to change to RD0. You can scroll down and select to RD0 because that is where we are seeing the output. So you have to see a waveform at the RD0 pin. So you have to select RD0 there. So I think there is a waveform being generated, but I'm not able to elaborate this. Like I reduced it to 0.01, let's see. 0.0001. Reducing the time is also not helping me out. Okay, let me see if this build got completed. Okay, so I'll load this file, reload last. Okay, so can you see it now? So weight was like literally high. So that is why we couldn't see. Can you see it now? Initially, LED, like initially you can see 50% duty cycle. So let me trigger it. Okay. So can you observe here? Time I have taken is one division is of 1 millisecond. So if you properly observe, let me highlight this much. Okay. So it's occupying 3 divisions for 1 pulse. Can you see that? So it has, yes, so slightly lesser than because I have just pressed this with. So you can see It is occupying 3 divisions for 1 pulse. So 1 pulse is being generated in 3 milliseconds. Okay, so 3 milliseconds at what it takes to get 1 pulse generated. So you can see how much is the frequency. You can calculate the frequency for 1 second. Okay, so 1 pulse being generated in 3 milliseconds. So for 1 second, you obviously will have more than 100 pulses generated. So that is why initially you can see the brightness is being glown with 50% bright. Then after that, if I press which one you observe, I press which one, duty cycle is going to increase. Similarly, I press switch 2, duty cycle is going to decrease. Are you able to observe this? So we did not concentrate on taking an exact period. So we just took period as randomly 100, duty cycle as 50. But we are able to see this uh, uh, clock pulse generated at a particular pin of the microcontroller with 50% duty cycle initially. So as I press switch 1, duty cycle is going to increase, and as I press switch 2, duty cycle is going to get decreased. So you can get an oscilloscope output seen in your simulator itself directly. So if you are not getting, please make sure you are making these settings. So channel 1 has to be 2 volts and has to be 1 millisecond. So triggering time has to be 0. Then triggering level, you can keep it as 5. Okay. So these settings you make, you should be able to observe the output. Is that clear? I actually have a default, one built-in template is already there, but this ID is being really bad. I don't know why. Not even able to load the project. And this is the first time it is behaving this way. I will relaunch this ID again. Let me if this is going to work fine this time. Else I have to figure it out how to make this work. So give me 2 minutes. Let me check. Yeah, so I was just checking. So I also cleared some of my system's space, assuming that it could be a problem. So I have right now got it launched. Okay, I think it should be working fine. So as I said, this is the program which we wrote. So here I have kept the weight as 500, and you were able to see the toggling of. You were able to see that you got a 50% duty cycle waveform generated at RD0 pin of the microcontroller. Now, similar to this project, we also have a template. So I'm going to close this and open that template. There is no much difference in the template to what we actually wrote. So if you look at the template of bit banging, so it comes under clock input output sources. So we will open pulse width modulation bit band. Second, observe there is no much difference. In fact, the only difference you will be able to observe is, so this digital keypad main.h, it is going to remain the same. So digital keypad obviously has no difference. So when it comes to the main.h, LED1 is representing RD0, LED array is representing 4D, and LED array 1 DDR is representing TRISD. So on is representing 1 and off is representing 0. So after this, if you see the source file in the main, so nothing is much different. So read digital keypad, as always we are reading it as level. Now what we are trying to do is, so in my case, in the program we wrote, so we were checking if the key pressed is switch 1 and we were incrementing the duty cycle there itself. And if key pressed is switch 2, we were decrementing the duty cycle there itself. And the LED was provided with 1 or 0 according to the duty cycle in the main function itself. Now for all of that, we have a separate function return called as the software PWM, to which I am passing the key as an argument. Now you can see duty cycle is 50, loop counter is a variable we have taken, wait is returned with 0, period is taken as 100. Now if not of wait minus minus, wait is assigned with 500. If key is equal to switch 1 and duty cycle is not equal to period, we are going to increase the duty cycle. Else if key is equal to switch 2 and duty cycle is not equal to 0, so duty cycle is minus minus. Okay, and here loop counter is less than duty cycle, LED1 is returned with 1, else LED1 is returned with 0. Loop counter is equal to period, loop counter is returned with 0. So this actually I merged it here itself, writing loop counter plus plus is equal to period. That's the only difference. Now apart from that, we don't have any other problem, but when we are using the bit banging method, your only focus should be to generate a modulated waveform at a particular pin of the microcontroller. So it need not be RD0 itself. You can get the waveform generated at any pin of the microcontroller. But the major problem here is, if you are trying to generate a modulated waveform at a particular pin of the microcontroller, so we have to make sure that we are not focusing on any other operations. Now just assume at some point of time, after I have generated the modulated waveform at a particular pin, assume I have some other operations to be performed. Okay, so I have some other operations to be performed. So I have written a blocking statement. So just to make sure that there is some other operations to be executed, but we don't know what other operations it is. I'm just having a blocking statement written. Now assume according to our expectation, so it has to be glowing with 50% duty cycle initially, and whenever I press switch 1, duty cycle has to be increased, and I press switch 2, duty cycle has to be decreased. So that is our expected output. Now after I have got the waveform generated, I have a small blocking delay return. So observe how this is going to behave now. I'm just waiting till build gets completed. So it's taking a little of time. I think from tomorrow onwards, I will keep the uh, executable already generated so that it will not consume much of the time. Okay. So now executable file got generated. Let me load it to my picking. So I'm going to file and load hex. So this is under templates. So template, then clock input output, then bit bank, distribute, default, production, the hex file. Can you see, is the LED behaving according to what we were expecting? Do you think LED is behaving according to what we are expecting? No. So we were expecting LED to global 50% duty cycle initially. And when I press which one, duty cycle has to be increased, which in turn increases the brightness of the LED. When I press switch to duty cycle has to be decreased, which in turn decreases the brightness of the LED. But in fact, it is actually blinking the LED. And that is not the logic we wrote. So that is because when you are trying to generate a modulated waveform at a particular pin with the help of the bit banging method, some other code you have written might disturb the way your program is actually working. So some other logic written, if you are concentrating on some other task also to be focused on, then that is not going to help you. So bit banging method can be used only when your major goal is to generate a modulated waveform of a required duty cycle. Now, if you want to take action apart from that, you want some other operations to be focused on, then it is not possible for you to go with the bit banging method. So in that case, you either have to make use of timer or you have to make use of the built-in block in order to have the modulated waveform generated. Okay. Also other logic than blocking delay. Yes, it can be anything apart from blocking delay. So I don't have any other peripheral to be taken care of as of now. So I'm writing a blocking delay, but in your code it can be anything other than this. Okay. So any operation you want to perform after this, it is quite challenging when you are doing it with the help of bit banging method. So whenever you have to do this, okay, so whenever you are supposed to have a pulse width modulated waveform generated at a particular pin, also consider doing some actions apart from this. Then you have to either choose it to generate with the help of timer or you have to generate it with the help of built-in block. Now, using the timer to generate a pulse width modulated waveform is a part of your classwork. I mean, part of your assignment. So let us concentrate on how to generate a modulated waveform with the help of a built-in block. Okay. So we are going to configure another peripheral. So our microcontroller comes with a built-in block which is capable of generating the pulse width modulated waveform of required duty cycle, also of required frequency. So you just have to specify how much is the frequency you need and how much is the duty cycle you want to get generated. So that is going to give you a modulated waveform generated at a particular pin. Okay. Now, so this time what I'm going to do is let me make use of a built-in block to have a modulated waveform generated. So for that we already have a template code written. So let me open a template code. I'll also show you how to configure it. So in order to know the pulse width modulated waveform of my microcontroller, in order to know the built-in block which is capable of generating the modulated waveform in my device, what should I be referring? So in my microcontroller, to know how the built-in block is capable of generating the modulated waveform? Yes. So I'm supposed to open the data sheet. Now, in this data sheet, let me take you to the table of contents. So here, if you go with the table of contents, can you refer this and tell me which section should I be referring? Can you look at this and tell me which section should to refer? Which section should I be referring? Yes. So it is section number 8, which is talking about 3 blocks in general. It is talking about the capture mode, compare mode, and pulse width modulation modules. So we are going to concentrate on only pulse width modulation. So section 8.0 refers with 3 different things. So capture, compare, and pulse modulation. So I want to focus on pulse width modulation only. So it is section 8.3. Now coming to this pulse width modulation mode, you can see in pulse width modulation mode, the CCPX pin produces up to a 10-bit resolution pulse width modulated output. So please understand, it is going the CCPX pin. There is a pin called CCPX pin which is capable of producing a 10-bit resolution pulse modulated output. Now, since the CCP1 pin is multiplexed with the port C data latch, the TRIS2 bit must be cleared to make the CCP1 pin an output pin. Okay, so I have to make TRIS-C2 bit cleared. So tell me, to which pin of the microcontroller CCPX pin is being configured? If I have to clear the TRIS-C2 pin, which pin is it talking about? That is telling TRIS-C2 has to be cleared. That means I have to write TRIS-C2 with the value 0. So which pin's direction is it setting? TRIS-C2? Come on. Which pin of the microcontroller's direction is being set? Yes, it is RC2. And RC2 is being made as what? Input or output? So it is output. So now remember, at RC2 pin of the microcontroller, your microcontroller generates a pulse width modulated waveform. Okay. So your microcontroller generates a pulse width modulated waveform of required frequency of required duty cycle at RC of the microcontroller. Now let us see the list of the registers associated to the PWM block. Okay, so actually if you see, this is the list of the registers. Okay, registers associated with PWM and timer 2. And in fact, let me take you to one register. Okay, now the capture, compare, and PWM modules are going to work together, and there are certain registers which are associated to it. One such register is the CCP1CON register. Okay, there is a register called CCP1CON register which is having 8 bits. This is bit number 0 and this is bit number 7. Out of the bits available, 2 bits of the CCP1CON register is unimplemented. The rest of the 6 bits are readable as well as writable, and they do have the initial value as 0. Okay. Now, bit number 5 and number 4, I'm going to use it later. Okay, so I will be using it. So bit number 5 and bit number 4, I'll be using it later for the same PWM's operation. Now bit number 4 to bit number 0 is to select which mode you want the working to happen, whether it is the capture mode, whether it is the compare mode, or it is the PWM mode. Okay. Now in order to select the PWM mode, what should I write CCPXM3 to CCPXM0 with? in order to write the uh, PWM mode. Okay, so I have to write one here, one here. These two are don't care bits. So you can write either a 0 or a 1 up to your choice. Okay, so to select the PWM mode, I have to write CCPXM3, CCPXM2, CCPXM1 and CCPM0 with 1, 1, don't care, don't care. Are you able to follow this? Okay. Now observe, I'm taking you to the main function. I'm showing you the main function. Oh, again, this is not responding. Guys, I'll do one thing. I'm going to stop the class here. So I'm not very sure what the problem is. I'll try fixing it by the next class. So it is not at all opening. I don't know what the problem is. Will that be fine? So it is again and again showing it is not working. Okay. So I don't know what the issue is. I'm not able to like flexibly use the IDE. So I'm not even able to scroll. So I'm very sorry for the inconvenience. I have no idea what the reason is behind it. So I'm going to continue the class tomorrow. Okay, the problem is just with the IDE. I'll have it solved as quickly as possible by uh, so meanwhile, please have your attendance marked and quit the session. I'm going to continue tomorrow. Sorry for the inconvenience and let me continue tomorrow. So you do have class tomorrow. There is change the plan. So this week you have class till Friday. Okay. So here is your QR. Please have your attendance marked and then quit the session. Thank you all. And I'm very sorry for the inconvenience.